In this video, we're going to be looking at empirical formula and molecular formula. Now, the first question, it says, a compound is composed of 52.14% carbon, 13.13 hydrogen, and 34.73% oxygen by mass, right? Now, I said, what is the empirical formula? And then 2, it said, if the molecular mass of the compound is 1338.204 grams per mole, what is the molecular formula, right? First, the question says by mass. So what this means is that, solution, what this means is that you convert the percentage straight into mass in grams. So you say carbon has 52.14%, right? So that will become 52.14 grams. Next, we have hydrogen. It has 13.13%. So you convert that straight to become 13.13 grams. Next, we have oxygen, and it has 34.37%. Therefore, we say it was 73 grams. Now, next, what we're going to do is we'll convert the mass in grams into moles. Now, to do that, we'll use molar mass. So, for carbon, to convert 52.14 grams of carbon into moles, we say, and using molar mass, we say for every mole, for one mole, for each mole of carbon, it contains the molar mass of 12.01 grams. Now, when you multiply, therefore what you do now is that grams will cancel grams, right? 12 divided by 52 is equals to 4.34 moles. Now, for hydrogen, we say for every 1 mole of hydrogen, it has 1.008 grams, right? Therefore, what you do now is grams will cancel grams, right? 1 divided by 13.123, right? 1.008 divided by 13.13, and what you have is going to be 13.026 moles. Now, for oxygen, I'm going to say multiply for every 1 mole of oxygen is equals to 16 grams. That's the molar mass. So grams will cancel grams. 16 divided by 32.73. What you have is going to be 2.171 moles. Right? Next, what we do is this. You look at the 3 answers: hydrogen, oxygen, and carbon. Oxygen has a list, so you take the one with the list, divide it through. What this basically means is that you're going to divide all of them by 2.171, right? So therefore you say divide by 2.171. So what you have now is going to be what? 1. Right? In this case, divide by 2.171, and what you have is going to be 6. And in this case, divide by 2.171, and what you have in this case is equal to 2. Now, please make sure that your answer is not in decimal points or in fraction, because you need your answer to be in whole numbers so that it will aid you to write the molecular formula. So with this, it will help you to write the empirical formula, So with this, we say the empirical formula of this compound is C2 2, H6, and O. You can put O1 or O, it's the same thing. So let's go to B. Now to find the molecular formula, we first of all find the molar mass of the empirical formula. So we know the empirical formula to be C2, H6, and O, right? Now let's find the molar mass of the empirical formula. So to find the molar mass of the empirical formula, we'll say 2C plus 6H plus O, right? Therefore, what we're going to say is going to be 2, then the molar mass of carbon is 12.1 plus 6, 1.008 plus 16. So therefore, what we'll have is going to be 46.068, right, grams. So this is the molar mass of the empirical formula. To get the molecular formula, we'll say empirical formula, which is what, C2H6O, has a molar mass of what, 46.068 grams. Now, according to the question in the B section, it says that the molar mass of the compound, right, if it is 138.204 grams. I should find the molecular formula, right? Now to do that, we're going to divide this mass, right? I'm going to divide the mass of the compound by the molar mass of the compound by the molar mass of the empirical formula. So therefore we'll say 138.204 divided by 46.068, right? When you divide it, what you get is 3, right? Now what this means is that for every, you look at the empirical formula, multiply this 3 by all the numbers, all the subscripts in the empirical formula. Now mind you, this oxygen, there's an invisible one here, right? So therefore you say 3 multiplied by 2 is 6. Therefore you write C6. 3 multiplied by 6 is 18. So you write H18. 3 multiplied by 1 is 3. So write O3. So this is the molecular formula of the compound. The second question says a compound consisting of 20.32 grams of carbon, 5.12 grams of hydrogen, and 7.9 grams of nitrogen. What is the empirical formula? That's A. B. What is a molecular formula if the molar mass of the compound is 236.448 grams per mole? Right? So solution. So we say carbon has 20.32 grams, that is the mass. Then we have hydrogen has 7.9 grams, and then nitrogen has, hydrogen has 5.12, 5.12, sorry. This is 5.12, not 9712. Then nitrogen has 7.9 grams, right? Now, next, what we'll do is this. We are going to find the moles of carbon, hydrogen, and nitrogen. Now, to find the moles, we'll use the molar mass like we did earlier. So we say for every 1 mole of carbon, we have 12.01 grams of carbon, right? Now we know that grams will cancel grams. 12 divided by 20, what we'll get is equals to 1.692, right? Next, we say for hydrogen, we say for every 1 mole of hydrogen, what we have, this is mole, sorry, right? What we have is going to be 1.008 grams of hydrogen. So grams will cancel grams. 1.008 divided by 5.12, what we have is going to be equals to 5.079 moles. And then for nitrogen, we say for every 1 mole of nitrogen, what we have is equals to, it's going to be 14.01 grams, right? Grams will cancel grams. So 14.01 grams divided by 7.9, what we'll have is equals to 0.5639 moles. Now you look at the three between carbon, hydrogen and nitrogen. Which one has the least moles? Is nitrogen. So you divide the moles of nitrogen by the moles of the rest. So here you say divide by 0.5639. So what you have will be 1. Here you say divide by 0.5639, and what you have here is going to be 9. Here divide by 0.5639, and what you have is 3. Right? Now whatever you have here, you use it to write the empirical formula. Now to write the empirical formula, we'll say C3, H9 and N. You can say N1, but it's still the same thing as N, right? So this is how you find the empirical formula, and this is our A. So let's go to B. Now for B, it says what is the molecular formula, right? So first and foremost, what we'll do is we'll find the molar mass of the molecular formula. So the molecular formula, which is what? C3, H9 and N, is equals to 3C plus 9H plus N. Therefore, we say 12.01 plus 9 1.008 plus 14.01. So therefore what we have is 59.112, right, grams. Now since we've gotten the molar mass of the empirical formula, therefore we say our empirical formula C3H9N has a molar mass of 59.112, right? Now for the compound, the molar mass of the compound, we know it to be what? 236.448, right? What is here, right? This is grams per mole. Grams per mole, that's the molar mass, right? Grams per mole. Therefore, to find the molecular formula of this particular compound, we'll divide the molar mass of the empirical formula by the molar mass of the compound. So what was basically saying is this: we'll say 236.448 divided by 59.112. So what we'll get is what? 4 when you divide it. Right? Now you multiply 4 by the subscript, by this subscript here. So 4 multiplied by 3, we have 12. So we have what? C12. Then 4 multiplied by 9, we have 36. Therefore we have H36. 4 multiplied by 1, there's an invincible 1 here, is equal to 4. So we have what? N4. So this is the molecular formula. Thank you so much for watching. Please feel free to like, share, subscribe, and drop your comments.